Before we go to context engineering, let's talk about short history of agentic AI with an example of how we reached here or what agents are promising with one good example of taking coding agents. What is needed to build agentic AI? That's where I'm trying to take you. What it takes to build agentic solutions with an example of coding agent. Okay, let's go 60 years before. 60 years before, if you wanted to write code, you have one programming language called C. This is a paper. I have a link for this. They're saying now use agents for context building too. So agentic context engineering. This is from Stanford, and they showed that at 60th step, this token size is the context they were giving. 18,000. It drops to 122, and the accuracy drops 10 points. Okay, good morning. I think these days, like at least first few weeks, it seems like in a new cohort, it always feels like that I'm teaching the same cohort class. Today is context engineering, challenges and tips for PMs. I will talk about what context engineering is. If you have questions, I'm experimenting something new today. I put a scrambler for all of you. This is for community. We do it in the cohort, but today I'm putting it here also. And a lot of Pooja and our team will make sure that you can put your questions. You can put your questions in chat. Our team can move it here. Ideally, you should move it here. Okay, then before we go to context engineering, let's talk about short history of agentic AI with an example of how we reached here or what agents are promising with one good example of taking coding agents. Coding agents, anybody know coding agents? What are coding agents? Give me examples.
Codex.
X,
Can I say lovable? I think the abstraction, I like them because they offer the highest level of abstraction. So non-coders can be coders. So that's, I think I put them on the very top layer, which is offer the highest level of abstraction in coding agent because they are writing the whole code for you. And you don't even need to know, but if you want to know, they give you the files. You can see they're writing the code, right? So I will call them coding agent with a very high layer of abstraction. And maybe the persona is not developers, and that's what Pujitha is giving me a reaction on, okay? So we are doing context engineering, but before we can do context engineering, I am taking a D route to figure out what is this idea of agentic AI with an example of coding agents that can write code. And we can apply this to anything, to be honest, like coding agents or chatbots or workflows that automate things in your office. But how, like, let's take the coding example and let's see like what is needed to build agentic AI. That's where I'm trying to take you. What it takes to build agentic solutions with an example of coding agent. Okay, let's go 60 years before. 60 years before, if you wanted to write code, you have one programming language called C. Basic, great, guys. So all you could do is if-else statements. And then something came 20 years ago, which is called DAG, which is anybody? It's easy to call programming languages names.
Directed
acyclic graph. What does that mean?
It's a workflow where there are no cycles and
Great. So you cannot
the
trace
graph
back
which
the arrows in this. You can only go forward. You can loop through things. On an event, you can react, and you can create a graph of nodes which do things, and there is nothing back. And this is how most of the work that any app that you see today, ATMs, your Facebook, any code that you have seen is based on some kind of a directed acyclic graph, which is a node of loops if else, and if then event happens, then that thing happens too. Good. Then, first time ever, we are saying that, hey, you know what? This was fun, but let's make a promise that on agents, you don't need DAG. So we are saying that, hey, how can we code without doing or knowing a directed acyclic graph or some kind of this idea of writing, if this comes, then do this, and there is only one flow. Let's break that. This is the first time these coding agents are able to break it. And how they work is based on an event, you can have different blocks of code or different things that you can do loosely given to some kind of thing which just determines the next step. Determine next step. And then when I go and I say, hey, create a website with lawnmowers checkouts, then it says, okay, there's an event. On that, I need to create a website. So I will call this page, this framework. I need to create an index page. Okay, on that index page, once it is done, it submits that work. Then it says, okay, I have this, but I need pictures. Okay, then get pictures. That generates another steps. And maybe that whole thing is called get pictures. And then it submits it to work again. And then it goes and says, now write buttons for checkout, for action with a database, update the database, create and update the database, then comes back again. And then it goes on and on till it has a website. Anybody, should I show you Lovable, or everybody's comfortable knowing what Lovable and how it works? Behind the scenes, there is nobody defining how these blocks need to be connected before the user comes in and asks. Based on the user event, it determines the next steps and creates whatever needs to be done at runtime. This is how all of the agents that you have seen, whether they are doing code or no code, are working behind the scenes. And that's the world that you live in today. If you live in that today, live in that world today, that breaks the DAG. So I'm showing you a kind of GIF which does a better work than what I was able to do on the board. But the idea is same, which is based on a user event. You come in and you say, hey, determine the next steps. Based on that, you call an API. Based on the results, you define this event has happened. I have called this API. This is the result of that API. Now let's define the next step. And then you keep adding this. All of this is the context that is getting built. And now, as product managers or engineers, you have to deal with this context before you go to the next step. Because this determine next step requires this context of what has happened before. Good. Now, figuring out how to pass this context, or defining what context need to be passed, or managing this context, is the art of context engineering. Good. Any questions? So far, we have just gone into history, and we got to figure out how the agents work and how on each step in an agent, there is context that is getting built. Okay.
Is the context same as memory? Like it's essentially.
That's a good question. We'll take it. Sheila,
okay.
just hold on to that. I will take it in a second. Rudy.
My question is, how do you know that you've reached the final answer?
Yeah, good. So this determine next step, this is an orchestration thing, which also has some kind of a way to know that it checks every time, have I reached the goal? If I not reach the goal, then it says, okay. That also is a system inside, which also need the context of what user wants to do. It has figured out what success looks like, and it compares to the success. And then it comes up with yes or no. And maybe just a prompt to an LLM saying, hey, have I achieved the goal or not? And if it says yes, you say yes. If you say no, it is no. Okay, I will take later questions. Just hold on. I just take 2 questions in between. So next time, just try to beat it. There is a race to fun. Okay, similarly, what I did for the code, the same applies to the chatbots also, right? When you ask them a question, which is like, hey, do a research on blah, blah, blah. And if you can see when they say thinking, they are doing many steps. They're saying, I would do this first, then I go do this, then I go do this, then I go do this. And eventually they combine and give you a report, right? But they are doing a lot of things, and they are building this context while they are doing the next step. They're building the context of the previous step. So now all of us know how, have a basic idea of what's going behind the scenes in the coding agents or any agents that you are playing with, that it is not solving everything in a single step, it's solving it in multi-step. That's the only thing I want you to take away. And if it does in multi-step, then it needs to know what happened before, right? And if you need to know what happened in before, in this community, we also know that agents have this kind of a structure that they have some kind of intelligence layer. We call them LLMs or foundation models or something. That is the intelligence layer. They also have a context of, what are the four things here?
Knowledge,
memory signal,
Knowledge,
tools.
tools. Great. So each step I need to do all this, right? So I have the context of what. So then I can have a table and I can define on each step what is the knowledge to answer this question. Look here, do this. If I want to define, like, reverse engineer it, then I know the perfect answer to a question or perfect thing. At each step, I need to define what knowledge or what database or what documents to read. Let's take an example. The example, if the person comes and says, hey, first figure out how many holidays are left for this year. And for the exact number of holidays, please book a hotel for me in Cancun. My budget is $10,000 and I have 2 kids. And I'm looking for a fully blah, blah resort. How many holidays are left? If how many holidays are left, I can specify what knowledge. I need to know my HR policy of holidays. I also need a signal, which is what kind of employee it is. Is it a permanent employee, contractor, right? Memory, we will start with the customer request, and then we have to build. And then tools, I will need tools like, in the first call, I just need to do maybe research. So search tool. That is it. And then guardrails, whatever guardrails you want to put in, is whatever the user specified or our system specified guardrails. This is a context that is needed. But this is not a one-step problem, right? First step is, first determine what is the user's number of vacations left. Once I have that context, then it checks and determines the next step, which is do research and find out resorts within less than 10,000 and rank them with the priority, kids friendly, in this area, whatever, I'm vegetarian and all those things, right? So whatever preferences I provided, or it can have previous preferences stored in our signals with the previous things they did with us. So that this context needs to change now.
So does it
And
sound
the
like
art
a
of
flowchart, Mahesh?
Yeah, so at each step, as a product manager, what you do is, what you can do is, which is you have to figure out what are the different contexts that our query will take based on a user request, and then fit it inside that context window. What is the context window? Yeah, so some user
Immediate
needs to
memory
send a
of
request and you send it to intelligence with all these things. The length context window is what you send, the size of that, all this information you are sending, that can be called context, and the window is how much you can supply it in one request. What's the limit on that? Is there a limit on it? It's or unlimited. I can send as much as tokens or words to this. Every time I query LLM, can I send everything, or can I have a limit?
Depends on the
Depends
Yes,
on the
there is a
model.
On
limit.
GPT-5? GPT-5 limit. GPT-5.
15,000
1
something.
million
Million?
tokens.
When we settle, 256K
One
was good enough,
session.
by the way.
It was unfamiliar,
Okay.
I think, but okay.
Okay, yeah, so let's continue. Okay, so 1 million tokens, that correspond to maybe like some 500 pages. The user need to just tell me that, and I can on each step give 500 pages of information to get better responses. Now, a good agent will have those 500 pages or 100 pages or 50 pages stuffed with the right context of memory, right context of what tools you should call, right context of what knowledge you should extract. And a bad agent can have 500 pages of just crap, right? And that's what we are seeing in the world. So that's the idea, that context engineering is this art of filling the context window on each step, not only once, on each step of that determining next step with the right context into this. And what is the ingredient of that? Memory, tools, signals, your prompt, your guardrails, all of these are the tenants, and you fill what is the value at that step, or your system fills that. Okay, so all of us have a common understanding of what is context engineering, at least
May I
some
ask
idea. Good enough.
if the context change each time there's an event, or
how
Yes.
do we up?
Yes. So every time there is a change in the event, or even within an event, one graph or one quick execution you do, this context need to change on each step inside that event also. So event is a customer comes and says, book my Cancun trip, right? And gives you some instructions. But on that event, you will build context, not for everything. You will first break it down and then say, for executing the next step, here is my context, which is the next step is first find out how many locations Mahesh have, because maybe he has 0 locations.
How does it impact
right?
the
And
memory? The memory is
it impacts the
previous
memory.
event.
Yeah, but the model context. So you need to see here, right? The context goes here. So it's not only memory, it's also what knowledge you will need, what tools, and what is the input to those tools, and what was the output from the tool. Tool in this case could be that I did some research on how many restaurants are in, how many resorts in Cancun with kids-friendly offerings under $10,000. So that would be your next step, right? So that's the context that came from that research that the tools did. Okay, then a context to AI is everything here: the user provided instructions, the guardrails, the memory, the tools, the signals, the knowledge. How is it different than prompt engineering? Anyone? This is fun, right? Because I can only ask questions. By the way, we're just getting started in this cohort. In this session, my name is Mahesh. If you don't know me, this is my LinkedIn profile. You can connect me. I accept connections. I am happy to help you in your journey in becoming a good AI PM or good builder in AI. If you sign up this form, we will invite you to these sessions automatically. So you need not to do it. We do these sessions every Friday. And all these people who are so cool here have done our cohort or either been in this community for long, and we can do the same to you. There's no privileges that they have. You can have the same by filling the form. That's it. Let's get back to, then people talk about prompt engineering, and context engineering is a new word in the prompt engineering world. Is there a difference? Anyone? What's the
So I
difference between
believe
prompt engineering, context engineering?
I think
One's a
prompt
question,
engineering is
one's
the
a
art of
background.
providing context.
Prompt is just one part of the context. Right?
Great. So prompt is what the user tells you, which is book me ticket. And then you can also have a system prompt, which is, hey, act like this helper or a concierge to these queries. So you will have a system prompt and a user prompt. But the context is much bigger, which is what you build on step by step, what knowledge you will need to solve this, what memory you will need, what signals and all that. So prompt is a subset. So prompt is a smaller thing, context is a larger thing. So I have written a lot list that you can look at different tenants and read through it. The idea is that prompt engineering is part of context engineering. That's all I want you to take away, and you can read more when you have time. Okay, then what is the impact of good versus bad context with real examples? So now you understood what context is. Let's go a little bit deep and let's see what is the idea of good or bad context, right? So good or bad context, what can it do? This is the CEO of Fox, Aaron. I like one thing about him is he writes continuously. This is what he wrote 1 week ago. He said that, hey, in the agent product management, it's just figuring out what is very smart person without any initial context whatsoever would need to perform the task successfully. By the time, every time they are debugging anything, it's just figures out, it's in their agents when they're figuring out anything. The challenge is that it's the wrong context. So every debugging becomes a context exercise. And if you got the right context, then LLMs or intelligent layer or GPT-5s are not failing you. It's filling the context correctly is what failing you. Good. So context is all you need. If context is all you need, then what's not working in context? So RAG is a way to get the right knowledge. And to extract the right knowledge, you need the context of what happened before, right? So if I know that I need the right knowledge, then I know what you told me or what I have done in first 3 steps. And in this paper or this source, they figure out 20 to 40% drop in a retrieval accuracy. We can't even retrieve the right knowledge because we don't have the right context from the previous steps. Similarly, 60% of AI failures or even 70% is just because we don't have the right context. And 45% of enterprise AI is failing because we have not thought a lot about context engineering. We thought a lot about, whatever. I'm not going to go there today. Okay. Let me give you a real example. So this is an app. We built this app. What it can do is a little bit of our marketing. Mahesh is built with so much marketing. So this is Legal Graph. This is the company that we gave name, and what we do is we help lawyers or anybody out there to basically not sign a contract without knowing what is in it. So what you can do is you can get our plugin from Word. You can upload any contract. This is an NDA. You can click Legal Graph. It will analyze this document, will take 1 minute, create a graph of what are the clauses, what is important, what's not. And then when you click Start Analysis, it will give you risks, right? So that's the tool. What happened in this tool in our own journey is that when we did it on an NDA, we said, hey, go ahead and tell me what is the risks in this NDA. And the response was, this looks mostly fine. There are some liability things, but not too bad. Yes, there was something about renewal, but did not see critical. Should be okay, but can revise if needed. This is a normal prompt, and the prompt engineering was very good. We said role, goal, instructions, and everything. Then we improved our context, and we gave it all the context. We said, hey, this is your system instructions. This is the user input. This is what we have in your short-term or chat history. This is the company policies. This is the retrieved knowledge from the knowledge bases. These are the two tools you can call. Actually, there is an indemnification disclosure that has no limitation. What does that mean? That if you sign this NDA, you will indemnify them for whatever amount they want you. There's no limit to it, which is a very critical thing in an NDA. Any lawyer will stop you, but our tool was not stopping it. But when we gave the right context, it started doing that, right? So that means that they can bankrupt you even if you just, let's say this company signed an NDA with you, and let's say you ended up saying their name or your employee ended up saying their name, they can just claim whatever damage. Whatever damage means they can claim everything your company is worth and your life, right? So you need to negotiate a cap on liability. And similarly, this agreement automatically renews successfully on 1-year term. That's a very bad term. That means this NDA applies to you for perpetuity. That means even if you spoke to them once and then you never spoke to them in 20, 30 years, and then also somebody came and talked about it, they will come and sue you. And this is left and right in these NDAs. But without context, our agent couldn't find it. But with context, it can find these real challenges. And that's what a good and bad product differentiation is. And that's why we believe context engineering is the thing that will differentiate awesome agents versus bad or average agents. And that's why I think it's super important for all of you to learn it. So what is not working? What is such challenge? So if context engineering is everything, then why can't we just go do context engineering? This is the right placement team. Just feedback for our team. They push these things in between. I put the deck and they push these things. This was after this. Okay. The next session is transformers. If you liked the session on neural networks that we did last week, which is on YouTube now, please watch it. I'm doing a similar session to make you understand transformers. Neural networks is much easier to understand. Transformer paper, the attention is all you need paper, is very hard to understand. And I will try to use my magic or whatever you taught me so far to decode transformers for you and explain to you how we are able to encode attention using machines. And that has unblocked everything you are seeing in GPTs or all this AI craziness. The foundation of that is transformers. And I will try to unbox that for you in a language that you can understand. So that's our session next week. If you have not joined our cohort, I want you to join our cohort. I think it's the best cohort. Everybody in the cohort says it's the best cohort. No, don't do that. But if you just begin, I think it's a really good time to join, because if you join now, you have only missed 1 week. And cohort people will tell you you have missed everything, but I think we can bring you back. But you start now, I think you can use holidays, and we can give you January also. So you have this good window of learning. We will be doing an interview prep as soon as you come from vacations in January. I come back from those 4 days, and that is free. And I believe just there is a lot going on, and without this, you will not be successful. So I highly recommend you to join the cohort. If you join now, you get like almost 3 months with us. So please do that. Now let's talk about problems. Okay, what are the main problems if agentic AI is figuring out automatically what steps we need to take to make jobs done or do things for people? And that is a step-by-step process. And each step, you have to provide a lot of context to be successful. And we just saw that everybody is saying, if I got the right context, it's like, who said it? If you give me a long enough pulley, I can move the earth.
Archimedes.
I think that's, thank you. See, a little bit of me there. Little you there, not me. But now the new saying is, if you give me the right context, I can solve every world problem. Okay, then what is the problem in giving the right context? One is context confusion. It's really hard to keep building this context, because when you start building this context and passing it to the model step by step, on one step you will say something, on the other it will say something, and you will have most of this is also irrelevant information that will go into this context window, and that will confuse the model rather than helping the model. That is causing, especially which tools to call. We saw only 30% accuracy. The more context we added, this reduced from 100% to 30%. That means if I give you tools like access my database, update my database, do search, book tickets, which tool to use based on the user query or based on that next step, the accuracy of that dropped the more context I added. Because there was just confusion, because in the previous step, it was this tool. And if I bring it back, then it was like, okay, maybe I need to call the search tool again. Because search is a solution to everything that comes with research. And now you start talking about it. That's why there is a lot of that confusion. And because of the confusion, the tool calling started failing 7 out of 10 times. So that's one problem. Second is clash. What happens is there is just contradictory information in this. So first step, you will say that this is a contractor. And in between, you did this search and there is some information that said that, hey, we give discount to contractors and full-time employees have this discount. And then there was this contractor or full-time. So now I have two things, full-time and contract. And then when I'm going to apply discounts, I just applied the discount of a full-time when I'm booking the tickets. So just there is a clash of information, and who wins that clash is not in user control. So the more information you put, the more probability there is that there is conflicting information in there, and that is causing a lot of problems. And then just the idea that there is a lot of distraction. The moment you start sending 500 pages of information with a user request of just 20 words, there's just too much information that the models don't even sometimes know what they're talking about. You have not seen that problem in ChatGPT, but behind the scenes, it's happening. They're just covering it up with their guardrails because they have put a lot of checks and balances, which you can't afford. So in your agents, if you just put blindly the context of everything and just start adding it, you will see it will just take a very different route. Yesterday, somebody was explaining in our cohort that when they go to Lovable or Bolt or this, then what they get is after 30 steps of building a website, after 31st step, this Bolt doesn't know what it is doing. It just takes you and start doing some screw up stuff. You have messed the context enough.
Hallucination?
Hallucination is like a small part. Distraction is you're just gone on a very different tangent. Right? It's just like a super. It's like a superset. I wanted to say somehow not in mathematical terms, but I chose superset. But the idea is it's a hallucination is like a very small thing. But at this time, it's not even hallucinating because you have distracted it enough, right?
So Mahesh, how is
read
distraction different than confusion? In confusion also, we are giving a lot of material, right? So how is that
Yeah.
different?
So in this, you have put confusing information. That is tendency confusing. This is, you have put so much information that it's getting distracted. So
Okay,
it's
it's
just like
volume.
abundance of information. And this is more like there is a confusion in the instructions that you have added in your context or some agent has added because the user is not adding it. The user just said, hey, I want to book tickets to Cancun. Please check out how many vacations I have and then book them. But you have to take maybe 27 steps behind the scenes. And by the time you reach 25th step, this is just 500 pages. And now I, as a LLM, I just don't know how to handle it because the larger the context, the larger the head, the stronger the headache. The good example of this is this paper. I think Ricardo sent it to me. So I ended up reading it. This is a paper. I have a link for this. They're saying now use agents for context building too. So agentic context engineering. This is from Stanford. And they showed that at 60th step, this token size is the context they were giving, 18,000, it drops to 122 and the accuracy drops 10 points, right? So this happens automatically. So the more context you were providing, as the context increases, your accuracy was also increasing. So the more context you were adding step by step, you had a good gain. But then suddenly at 60th step, they saw it dropped significantly. And after that, you have to start from scratch. That
Is
means
this
for a
for all
user,
LLM? Sorry, Mahesh.
sorry?
Is this for all LLMs or for GPT-5
Means
specifically?
I think they put an experiment, right? And they were running experiments. So they might
Okay.
have validated for all or some. But the idea was that the larger the conversation goes, the higher chances of you filling this context with something crap and eventually it breaks out. And after that,
Then
your LLM has to start from scratch in accuracy, which for a user will be a very surprising event. Here you can just looking at a graph, but here suddenly it asked me, hey, how can I help you? This happened with my son, by the way, yesterday. He was playing with ChatGPT. We play in voice mode. He's just 4-year-old. So first 15 minutes we play soccer, and then next 15 minutes we do a quiz, and we keep ChatGPT in between. And then we were asking a lot of quizzes questions. And at some point, what happens is it just said, hey, how can I help you? And he was like, I was talking about fruits and monkeys. And then they were like, yeah, fruits and monkeys are great. They go together. He was like, but we were doing this question. And there was no context left at that point. I was like, dude, you have no clue what happened here behind the scenes. They forgot everything that you have done. They are going on a very different tangent. And then he was like, this is so stupid. I'm like, yeah, this is so stupid because you think you're talking to somebody who is listening to you all along. But here, you're talking to somebody who just forgot or have too much that it has taken a very different route in the next step and is going on a very different tangent. And there's no way for me to bring it back here. Right? So if you understood what is context engineering, if you understood what are the challenges, then so what? Why should you care? Right? Let's do that in 5 minutes and then I leave you. Every time I do these sessions, I want to focus on now what, and I ended up focus on what a lot. So hopefully one day we will reach there. First step you need to do is you need to write better requirements across these context specific things. So you need to write requirements for memory management, context size and structuring, what is tools retrieval, what is observability and safety on your agents. That's your responsibility. Nobody's coming and saving it from that. So stop like saying that this is input output. Say for this input and this output, I need this context. So provide a table in your requirements on each step. Take a sample conversation. So when I was at this large search engine company, we were just debating how should we give the best requirements to engineering. And we came up with this format of left-hand side, we will say, user asked this, our response is this. On left-hand side. On right-hand side, we created a table. And in that table, we said, this is the knowledge you will need to extract. This is the tools response we want. These tools needs to be called. This is the response. This is what ideally should go in memory. And that's the kind of detail we provided them on 5 most occurring conversations on our agent. We're building a support agent, right? So first we provide the requirement, then we provide examples too. So at least for 1 example or 5 examples, our coders can check, are the tools retrieving the right thing? Is the memory getting handled? Is the knowledge doing the right thing? and they are meeting us. Then if you can define the requirements, you can define the criteria also. Context aligns with the user goal and intent. How many times that happens? You can check that in the conversations. You can have logging and you can check the context, and you can build another LLM and say, this context was relevant to this query and not. So when my son's banana and fruits example drops, it will flag it and your helpfulness score will drop. And then you can say, okay, it's dropping for these kind of conversations. We need to change the code or assign a bug to. So this is your criteria. This is the source being attributed. You can attribute to a source, or it's just some context that got built and now it's just a hanging thing. And then you can also define PII. I will give you a detailed list of these. If you can do that, then you can set the correct scorecard. Because if you can't set the right dashboard or right scorecard, then you can't make cross-functioning team towards the right goal. Right now, everybody is going towards the goal. How can they launch the best next agent? Or how can they bring AI to their company? But you say, hey, what is our intent alignment score of your agent? That's a metrics you follow. How will I know what is my agent aligned to the intent? Because I have done this one. I will take the aggregation of these, and if it is not aligned, then this score percentage of this is lower. What is the noise ratio? How much of the tokens we are fitting in the context are relevant, and how many are just waste? And your goal as an engineer is to increase your intent alignment and decrease your noise ratio. Good. I put more here for you to think about. This is only I created. I don't think it's still in textbooks, and influencers don't have them yet unless they watch this recording, and then they can create a fancy chart of it. And then they will tell you that AI is changing everything. This is the new way of doing things and all that. If you want to stay ahead, these are the resources. There are a few papers I have read to just make sure that I can land these ideas better. This helped me design this content. So you can get the source also and get more information. If not, then we talked about what is context engineering. How is it different than prompt? What is the impact of a good versus bad? We said what is the requirements that you should be writing? How can you evaluate? And then how can you set your scorecards? By the way, Mahesh, I think all of us, even if we are small, we can defeat the big guys in the new world. And that's the mission I'm on. I teach a course, but I'm also start to build a company. I believe that small people can do big things if we align the technology to our values and do big things without being backed by big investors who just throw stuff at you like in context engineering. Okay, then I will see you again next Friday. We will go back to the world and see how transformers work. Bye, team.